Hello and welcome to this Pluralsight presentation. My name is Andrew Mallett and I'm here as your instructor to help guide you through configuring RAID on your Linux systems. This is all ready to support Objective 204.1 from the Linux Professional Institute, or the LPI Level 2 certification, and the 117201 exam. For the lab setup, we're using CentOS 7. It's a virtualized system and is set up fresh, so not carrying on from the other modules within this series. We'll be looking at adding in additional 2 drives to support traditional Linux RAID, so it's going to be SDB and SDC, and we've added a further 2 drives, SDD and SDE, which we're going to use to demonstrate how we can set up RAID on a BetterFS or BTRFS file system. If we take time to peruse the menu for this module, we'll be looking at software RAID, understanding what software RAID is. We'll be looking at the different types of partitions that we can use for RAID, so FD and DA. We'll be looking at using the MD ADM administration tool, and of course the runtime file /proc/mdstat. The configuration file where we can persist our RAID configuration, mdadm.conf, and we'll finish up by taking a look at how simple we can make life by using RAID within our BetterFS file system. RAID itself, we might look at, actually doesn't really mean anything these days, but it actually stands for a redundant array of inexpensive disks. And it's normally there to provide a level of fault tolerance. We don't have to use it for fault tolerance. We can just expand our data across multiple volumes, or we can stripe our data without fault tolerance, but usually it's there to provide a level of redundancy for our disk arrays. We will look at traditional Linux RAID first, and with that we create virtual device files underneath our dev mapper directory. Once we've seen that, we'll then get into integrating RAID with BTRFS, so we don't have to worry about all of the extra controls it's built into the file system. We also have different levels of RAID. With linear, the disks or partitions do not need to be the same size, and we just expand the volume across the disks supplied, and there is no redundant or spare disk that is supported within a linear array. Similarly, with RAID level 0, we have the same type of structure, but in this case with RAID 0, we use partitions or disks of the same or similar size. RAID level 1 we often call mirroring, and is used then to mirror the data between 2 or more devices. So whatever I write to disk 0 is mirrored to disk 1. With this we have a high level of redundancy, but also we use extra disk space. So if I've got 2 1 gig drives that I mirror, we've only got 2 gig of space. When we look at RAID level 4, 5 and 6, we make better use of the space, but still have redundancy. So we have to have 3 or more devices with RAID level 4 and 5, and 4 or more with RAID 6. We write to, let's say, 2 devices and write parity information through to the 3rd device. When we're partitioning up our disk, traditionally we have used type FD as our partition. With this though, this was the original partition type where we used the initialization RAM disk. But now where we have the initialization RAM file system, it's more appropriate and recommended to use the type DA. So DA is marked as type non-file system, and RAID Auto is the FD type. So on more modern systems we should be using the partition type DA. Now of course, once we have set up a partition table, if the disks are similar, we can then use sfdisk to dump the partition table from disk 1 onto disk 2. So if we use fdisk to partition up /dev/sdb, we can then use sfdisk to dump the partition table from SDB onto SDC. So we pipe the output from SFDisk to the input of SFDisk. In this way, it becomes a very easy mechanism to duplicate our partition table. So let's use this trick and see how we can set up partitioning for our system.